وصلاة الله وسلامه على رسول الله وعلى آله وصحبه أجمعين. أشهد أن لا إله إلا الله وحده لا شريك له وأشهد أن سيدنا محمد عبده ورسوله وبعد رب زدنا علما سنقرئك فلا تنسى واعلم كما لم تكن تعلم وكان فضل الله عليك العظيم. أسأل الله الكريم رب العرش العظيم أن يجعلنا علما نافعا ورزقا طيبا وعملا متقبلا سنقرئك فلا تنسى. Alhamdulillah, we thank God Almighty Allah for sparing our life till this moment. Last class we discussed probability. We solved one or two questions on probability with use of dice and coin. Then I told you that typical sample of coin is not with me there, and we discussed about playing card, the use of playing card, that is joker. Today inshallah we want to progress on that of coin, dice and card, on the issue of combining outcome. What do you mean by combining outcome? Last class we discussed on one coin or one die. That will have this outcome. A coin will have a tail and a head, which is 2 outcome, and a die will have 1 to 6, which is 6 outcome. And I told you that in a card we have 13 hearts, we have 13 club, we have 13 spade, and 13 diamond. I thought that the diamond and heart, they are red. White, spade and club is black. But today we want to see what will happen if you throw together 2 coins at a time, or you throw a coin and a die together at a time, or you have to throw coin and pick card at the same time, or they want to throw and spread card at the same time and somebody should pick. So now what will be the outcome of the combined action? Don't forget that throwing a coin is an experiment, throwing a die is an experiment, picking a card is an experiment. Now 2 experiments are now joined together at the same time. We want to see their outcome. That one by combining outcome. Are we together? That one by combining outcome. When you are doing experiment of coin and die together, or 2 coins at a time, or 2 dice at a time, there are ways of getting that. One way of getting that is list of outcome. You list out all the outcome. For the first action, the first experiment, you list out the outcome. The second experiment, you list out the outcome, then you combine the outcome. Another one is use of sampling table. I call it space table. Use of space table. The sample space will be listed on a particular table, and the table now go out to you the combine of the sampling space. That is, we call it space table. Another one is called tree diagram. The diagram will look like stem of a tree, and at the end of the tree you have the combined outcome being sold. Let's see how that can be done with this sample. Example 1. You have to list all the possible outcome of tossing 2 coins at a time. 2 coins is being tossed at a time, and you are asked to find the probability of getting at least 1 tail, B 2 edge. Firstly, you have to list out all the possible outcome. You have to list out all the possible outcome. In that case, we know that the possible outcome for that, possible outcome for 1 coin will be the first coin now. First coin we have what? We have head and tail. Cleared? Second coin must also have head and tail. How can we now combine it? Let's do it this way. We want to combine first coin now. First, second. See? For the first coin, as soon as you have edge, second may also show edge. Are we together? The first can repeat edge again. Let's assume it's edge again. And while the second is showing tail. Is it possible? If second is showing tail, second can showing edge. Is it possible? If first is showing tail again, your second can also show tail. Is that possible as well? Oh, I don't think you can see. Can you see the board? Look at this. Can you see like that? Let me repeat myself. We all agree that first coin have the capability of showing edge and tail. Showing edge and tail. Second coin also have the same capability of showing edge and tail. Now let's try to combine. For the first coin can show edge, and as well the second also show edge. So in that case, you have edge. Are we together? If first is showing edge, second can show tail. In that case, you are having what? Edge, tail. Are we together? If first is showing tail, your second can show edge. Abi? In that case, you are having tail, edge. Is it clear? If your first is showing tail, your second can also show tail. In that manner, you are having tail. That is the combined outcome. Using listing out the outcome of each coin. I think I'm communicating. Let me repeat it. You want to throw a coin at the same time? You can throw, and the first one show head, second one also show head. It's possible. You can throw, and while first one show head, second is showing tail. It's possible. Shall that's called possible outcome. Okay. You can throw, and the first showing tail, second showing edge. Is it possible? Yes. You can throw, and the first showing tail, second showing tail. Is it possible? Yes. Now think of another possible one. It's not nothing else is possible. It's either the first is tail, second is tail. The first is edge, second is edge. The first is edge, second is tail. Or the first is tail, second is edge. That's all. This is possible combined outcome of 2 coins. Now to the question. You've listed out all the possible outcome now. You've listed out all the possible outcome now. The next question is what? To calculate at least one tail. You don't look at it. When we can have at least one tail. Check this. We have no tail. Check this. We have at least one tail. Check this. We have at least one tail. Check this. We have at least one tail. Is it clear? Yes. If that one is clear, let's go further. So at least one tail now will not be the event. I mean, probability of at least one tail will not be equal to number of one tail all over sampling space. What's our sampling space? All the possible outcome. What's the number of our one tail? The three circled outcome. Are we together? So in that case, we have number of one tail is 3. One tail can show 3 times. All over the total possible outcome is 4. That is the probability. That is the required probability. As simple as what? ABC. As simple as what? ABC. Don't worry, I will show you the table and the tree using this. But I want to calculate first. And I will not repeat the calculation. I will just show you the table and the tree using that to something. Are we together? Okay. Let's do the second question. Let's do the second question. Hope you have copied that. Let's do the second question. Second question is probability of what? 2 edge. Probability of 2 edge. Probability of edge. That will give us number of edge. Number of edge over sampling space. Look at it. How many edge we have? We have only edge. Only one place. Edge can appear once. So in that case, we have 1 over sampling space 4. That is the probability you are looking for. Very simple as ABC. The simplest aspect of mathematics is probability. Just have to think. Are we together? If yes, let's copy that and know how to try the table and the tree. This list out method. You list out the outcome so you can get the combined outcome. You list out the outcome so to get the combined outcome. Cleared? Let's see the the table aspect of it. 2 coin. Table outcome. 2 coin. 2 coin. 2 coin. Using table. Using what? Let's call it space table. Sampling space table. SSP table. Sampling space table. Sampling space table. The table will look like this. You can make it up like this. It can be at the bottom, anyhow. But let me use that of up. So that means we're going to make it up down. Let the first coin be here. The first coin. We have edge, tail. Do you agree? The second coin. We have edge, tail. Do you agree? Now, let's combine. You can make it from bottom like this. Head, tail, head, tail. Anyhow. Are you getting it? We want to use top down. Let me use top down. Now, for the first edge, under the second will be edge. For the first edge, under the tail. For the first tail, under edge. For the first tail, under tail. That is the outcome. That is the outcome. And then edge under edge under tail, tail under edge, tail under tail. If you can count, you see we have 4 outcomes the way we have it here. The way we have it here. Is it clear? Can you see the word clearly, please? That's all. That is the table. Here, your sampling space will now be edge, edge, head, tail, tail, edge, tail, tail. The same thing as yours we get there. Are we together? Are we together? If that's clear, then let's go for that of 3 and see how can you get the 3. Copy that? Is that copied? Good. Let me clean this. So you can compare that one too. Let me clean this. Thank you. Thank you. Look up. For 3, the 3 diagram looks like this. First coin, calf, edge, tail. This is the region for first coin. First coin. Okay? Second coin. We have when you have edge, your second can be edge or tail. Let me play this first. When you have edge as first, your second can be edge or tail. Are you together? As your first is edge, your second can be edge or tail. This second. As your head is tail, your second can be edge or tail. Are we together? This one will look as if we are using 3 coins. No, we are not using 3. It is only 2 coins. The first coin shows edge. The second can be either head, tail. That one has gone. Leave that aside. As your first show tail, assume your first has show tail, your second can be head or tail. That one is another aspect. Is it cleared? Oh, it seems I'm just doing magic. No, it's not magic. Just listen and wait. You want to throw 2 coins at a time. You throw one. Assuming you have edge, the first one that first land, palm, shows edge. Before the second one reach the ground, you can determine whether it's head or tail. You throw the 2 together, they can't reach the ground at the same time. Agreed? Go and try that. Take 2 stones outside. 2 stones. Throw it at a time. One will move further than the other. One will reach ground before the other. That's normal. Depends on the gravitational force of that thing you are throwing. Even if they are of the same size, if they are of the same weight, one will reach the ground before the other. Clear? So if that is the case, the first one reaches the ground, shows edge, before the second one reaches. You know, probability is a method of predicting before the thing happens. Probably it will happen. Okay. Before the second one reaches the ground, you will predict it may be head or tail. Cleared? If it happens that the first one reaches the ground and soars tail, the second that is coming can be head or tail. Is it clear? Am I communicating? If that is the case now, we want to trace the tree and write out our outcome. Let's trace this tree. Head, head. So we have head, head. Cleared? We are coming. Head, tail. So we have head, tail. Am I communicating? Trace it. Tail, head. So we have tail, head. Am I talking? Trace this. Tail to tail. So we have tail, tail. Are we together? Is that thing clear? I believe it's clear a bit. Can I explain? That one will be clear a bit. So that is that about tree diagram. And you use this outcome to calculate the question given as we did the other time. That is that about tree diagram and table. And sampling space table. This one is called tree diagram. What do I call it? It's called tree diagram. Tree diagram. TRW. Tree diagram. TRW diagram. Tree diagram. Are you getting it? That's called tree diagram. Am I together? That's what called tree diagram. That's what called tree diagram. So let's see second question. Let's see one question more, so we can quickly do better thing on that. Second question will show us two different things. Let's see second question quickly, and from there we can call it a day. Two different things. Second question, you can copy from my mouth. It says that. It says this. Stop up. A fair coin and a fair die. A fair coin and a fair die. Let me write. Together. At the same time. Let me read for you to see clearly. My marker is plugged somehow. A fair coin and a fair die are turned at the same time. Okay? Full stop. What is the probability of getting a head 5? B, a tail an odd number. A tail an odd number. It is possible we use a list out method. It is possible we use list out method. It is possible we use a sampling space table. It is possible we use a tree diagram. But inshallah, I would like to use tree diagram and table. Then to use table and then back it up with tree diagram and I will give you chance to do the calculation yourself. So let's quickly see. I'm giving you just a few minutes for the calculation, but let's see the diagram first. Using diagram. Let me use bottom top diagram system. Bottom top now. My dice is here. My dice will have, I said bottom top, from bottom. 1, 2, 3, 4, 5, and 6. That is the outcome that can be shown by my dice. Agreed. My coin will be here. My coin can only show head and tail. Do we agree? Can we see? Yes, you can see. Yes. So, as my dice showing 1, my coin can show edge. So we have 1, edge. Here we have 2, edge. Here we have 3, edge. Here we have 4, edge. What do we have here? Sorry. What do you have here? Don't forget, you have 5 edge or edge, 5. They are the same thing. It shows edge and 5. So it means on their own they count edge first before counting I'm counting that one first. No, it doesn't mean anything. Cleared? So the element is not anything. That means I'm taking my die first because before my coin. They are taking their coin first before their die. Cleared? So here we have 1, T, 2, T, 3, T, 4, T, 5, T, 6, T. That is the outcome now. The outcome will be what? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 sampling space. Agreed? We have 12 sampling space. Now the question says, hey, head and 5. You look at where you can have head and 5 or 5 and edge. It's only this place you can have head and 5 and edge. Cleared? So in that case, your problem is what? Number of head and 5 over total number of sampling space. Can you tell me that? Okay. Number 2 is saying a tail and odd number. At least a tail and odd number. We have a tail and odd number. 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 Can you get that? What's over? Abby, sorry. I'm sorry for that. A tail and odd number. Give me that. Give me the answer. Can you give me the answer? For the first one, 1 over what? For the second one, 1 over what? So, let's quickly see what will happen when we use 3 diagram. What will happen when we use 3 diagram? So we are coming to the solution of that question. That question A and B after the 3 diagram. Let's do it this way. Our head first. Our coin first. Our coin first. Coin can have edge or tail. Then our die. Die will have how many outcome? Can be what? 6, 5, 4, 3, 2, 1. Likewise here too. 6, 5, 4, 3, 1, 2, 1. Save it. Trace the first tree. We have edge and 6. The second tree, edge and 5. The second tree, trace the first tree to the third one. We have edge and 4. We trace this, edge and 3. I hope you are following my movements. Look at this. Edge and 2. Are you following my movements? Edge and 1. Do you agree? Yeah, second tree now. Tail and 6. Tail and 5. Tail and 4. Are you following? Tail and 3. Are you following? Tail and 2. Tail and 1. Are you following? So that is it. That is it. If you look at that outcome now, you see we have 6 outcomes as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The same outcome we have there. From there you can check. Age and 5 is only how many? It's only 1. As well, 1 over something will be probably there. Likewise the other 1 too. Let's quickly see the solution. The solution now. Hope you have chance to quickly do your solution out there and you listen to my own solution now. The set 8, 5. Probability of what? Probability of age and 5 will be, how many times can this show? Number of age and 5 is what? Over sampling space. That will be, number of age and 5 is what? 1. Over sampling space, which is 12. It is 12. That's it. That's it. B now. B now. A tail and odd number. You look at where you can see tail combined with odd number. You can see this one is tail and even number. No, it's not that one. But this one is tail and odd number. Tail and 4 is even. I mean, tail and 5 is what? Also there. So in that case we have probability of tail and odd will be equals to number of tail and odd all over sampling space, which is what? Which is number of tail and odd is 3. Sampling space is 12. It's finally 1 over 4. Are we together? So my dear students, I want to believe you can combine 2 or more experiments now to get combined outcome, and you use that one to find probability of any question asked. So Bismillah ta'ala, this is where we're going to stop our lecture for today. And inshallah, I promise to give you an assignment. Oh God. Actually, I did not bring my textbook here. So inshallah, I will send the assignment through the assignment page, inshallah. So this is the end of today's lecture. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk. Wassalamu alaikum wa rahmatullahi wa barakatuh.